So we're at the point in the course where we need to review logs and natural logs. Now, you would have learned this information in whatever prerequisite math course you would have taken for this course. They have all different numbers, but you would have learned working with logs and natural logs in that course. So this isn't meant to teach you logs or natural logs, it's just a review of the properties. So they have the look of this over here at the top, or you also would be seeing like an e raised to something. So that's the look of a log or a natural log. We have several equations that will be coming up where you have to work with the natural log key, or you have to work with a variable that's stuck either in the exponent position or like in the natural log position. And so we're just going to go ahead and deal with it really quick so that you're ready to work with them, you remember it. So in General Chemistry 1, you would have seen possibly something like this. That would have been like a P, but where you need to solve for a variable. And the whole rule with math is that you can do anything to the equation as long as you do it to both sides. So it's really important for what we're about to do with the logs. But in this case, we ended up moving the x around. And the whole reason was because there are times when you're solving for a variable that's not in a good position to solve for. It's not a good idea to solve for a variable in the denominator because you have to remember at the end to take the inverse, and a lot of times people forget to do that. So instead, we multiply both sides by x, and then we get rid of the x, and then that moves the x over so that it's not in the denominator. And then again, we can't solve for x when it's with something else. It needs to be by itself and equal to something. And so then we divide both sides by v to get that over to the other side. So you essentially have the x. And this is the format you really want an x to have if you're solving for a variable. You want it to be not in the denominator, not in an exponent, not stuck in a log. You just want it sitting there as an x equals something. So that's the goal. So when you're looking at natural logs or logs, you might have something that looks like this format or this format. And again, this is not good. You don't want a variable inside a log, and you don't want a variable in the exponent. You just want the variable just by itself, just looking at you, not in some weird format. So remember, you can do anything to both sides. When x is in the log, that's going to be the first scenario we're dealing with. There are two identities that you can work with. And so an example of x being in the log, I've got it written down here. This is the x, it's in the log, so it's not by itself, equaling or whatever. And that doesn't mean multiplied by, it's tied to the log in this format. And same for here. So this rule, it's really similar. That's why I'm presenting it at the same time. And the rule is that if you can get it into this format, you can then substitute just that the x equals that. So what I want to do is I want to get this left-hand side in this same kind of a format. So what I need to do is do 10 raised to the, and that's how I can get this left side in that right format. But, because now you can see it matches, you can't do something to just one side. You have to do it to both sides. So 10 raised to the. Now, because I know that's equal to x, this is just an identity. You would have learned this I don't know, at some point. It would have been like in the list of identities at the back of your course, something like that. But when it's like that, that means x equals 10 to the 2.3. And you can put those numbers in a calculator and you can solve it, no problem. If you have an ln, ln means it's a natural log, which means base e. E is like a number like 2.33, blah, blah, blah. And so we just use e to represent that particular number. Logs are base 10, so that's why we use 10 raised to log. E's natural log has the same kind of relationship. We just use an e instead of a 10. So in this scenario, to get that x from inside from being connected to the natural log, we do e raised to the, and then you can see that becomes just x. So I'm just substituting in this part for the left-hand side, e to the 2.3. Now, kind of the shorthand in this, so you don't have to keep writing stuff out, is a lot of times when you get to e raised to log, people will just write like this. Kind of like up here, when you would have divided by both sides, like when the x was on the bottom and, you have x, and then people will just cross it out like that. That's the same format. You'll see that in like a lot of work and videos for this course. So if you get to that format, like I said, the shortcut is just to cross it out. So that's how you get rid of an x inside a log. So that's something you're going to be dealing with the equation that's coming up in this lesson. But that's not the only time it's going to pop in and out of usefulness throughout the whole semester. The other situation is when x is in the exponent. So right up here, x being in the exponent. So I've got like an example. See, you can't solve for x very well like as an exponent. So what you do is, this has a log in the front. So you're actually taking the log of both sides. So I have to scooch this 4 over just a little bit. And again, you have to do it to both sides. And when you do that, again, it's x, it becomes x, and that's log of 4, and you would just put log of 4 in your calculator. And then like before, people would just write that as canceled out. It's kind of like saying 1 or whatever. And on the right-hand side, you would do, for this equation right here, again, my x is in the exponent. Because it's an e, I would use natural log of e. And then I need to be the natural log of 4. Let me scooch the 4 over just a little bit. And then that would give me, again, I'm substituting x equals natural log of 4. And people would just cross out like that. So those are the dandies you need to know for this semester. I'll put this lesson in every place that it needs it so that you can reference it. But I also, last little bit is just to point out on the calculator. This is a TI kind of a calculator, but you'll notice if you look on the left-hand side of my calculator, it's like 4 buttons up. There's log. So that's my log key, but the 10 to the part of it is actually in the second menu. So I have to click second to get it to say 10 to the. It's really light gray on my calculator, but hopefully you can see it. And then my ln key on my calculator is just below it. So ln, but if I need to deal with the e part of it, then I need to do second ln, and that gives me my e to the. So your calculator may be different from this. Just make sure that you worked out so that you know what it is.